Hello, this is a video for the individual presentation, the capstone project, in our case, group 7, determining the price of Airbnb nightly rentals in New York City. Um, the first deliverable and task that we needed to do was to uh outline the dependent variable and the proposed independent variables with respect to this assignment, and the ones that we chose. I mean, it seemed the dependent variable was given to us. It was price. And the independent variables that we selected that we thought might be the most interesting to look at were room type, neighborhood group, minimum nights, number of reviews, and calculated host listings count. We thought those all might have some kind of interesting correlation with the price of an Airbnb in New York City. For two of them, we needed to create a dummy variable so that there was numerical data to go off of, and that was room type and neighborhood group. So what we did then is we outlined all the descriptive statistics, the summary statistics for each of the variables, including the dependent variable. And we outlined some interesting findings for each. Um, in the case of the dependent variable, um, we thought that it was interesting that the data was skewed and that there was a significant kurtosis within the data set, which means that while skewed, there is actually a heavy proportion of weight in the tails of that data set, which is interesting because just means that there's a decent amount of sort of, I guess, far end higher end Airbnb prices in New York City, at least given the data set. Some other independent variables, we thought there were a number of interesting things, but one thing that kept sort of recurring over and over is that the data was skewed to the right, meaning that there seemed to be some kind of trend for outlier statistics there, pulling that data set and that normal distribution, or otherwise would be normal distribution, to the right. And you can see that in comparing the mean and median values in each of those data sets, where the mean the mean is greater than the median in a lot of cases, meaning it's those high end outlier values are pulling that mean in that direction. Um, Now, what we thought, we try to give some predictions based on what we were thinking with those dependent variables and which ones we thought would be interesting and how we thought that they would correlate with the price of an Airbnb. For minimum nights, we actually predicted that as the minimum number of nights required for a listing increases, the price of the listing will decrease due to the flexibility allowed within the lack of the minimum nights requirement. So essentially, that was the correlation we thought there. For number of reviews, based on some more general data about reviews, we thought that since reviews, generally speaking, tend to be more negative than positive, we suspected that the higher the number of reviews there were, the less satisfactory the listing would have been in the past, and the lower the price will be. That was probably one we were less sure about, sort of going into it, but was what we suspected. For host listing count, we suspected as the host listing counts increase, the prices will be higher because such hosts are more experienced and have a better understanding of the market. In addition to some other factors. For room type, this one was, to us, it was one of the more obvious, what we thought would be correlations. We suspected that listings for the entire house, as opposed to a shared or private room, we expected those to be higher. I mean, it's just more general privacy and features involved with an entire house versus just a private room. And for the neighborhood group, we suspected that listings in Manhattan would be more expensive than any non-Manhattan related Airbnb listings in New York. So then we got into the data and started looking. We chose a couple of pivot tables to express what we thought would be some interesting features of the data, and the two more obvious ones that I mentioned in the previous section based on our predictions, we outlined those, and there certainly seemed to be a a definite correlation there. For the room type, it turns out that the average price of a listing for a room type of entire house is around $211, whereas if it was not an entire house and it was a private or shared room, it was closer to $88. So there was a significant difference there in the pivot table and finding the average price of those rooms. And similarly for Manhattan versus non-Manhattan listings. Manhattan listings were about 196, whereas non-Manhattan listings were about 117. So there does seem to be some significant differences there, and that is actually corroborated by the correlation data that we also looked at. What we included in the final report was the correlation for what had the highest, I guess, correlation to price and what seemed to have the lowest correlation to price based on the 5 different independent variables that we chose. The highest, it turned out to be the room type. So whether or not a listing was an entire house or not an entire house seemed to be the highest correlated with how expensive that listing would be. It has a, based on the statistics, it has a 0.26 correlation coefficient. And actually what has a slightly negative but very, very small negative correlation turns out to have a negatively correlated with the number of reviews. So this actually confirms our suspicion. So as there are more reviews for a listing, the price does tend to be slightly lower, but the correlation factor was much smaller, and we included that in the final report for this data. And then on to the regression output. We went a number of different ways with this and looked at a number of different features, but looking at the T statistic and the p value is the most important features here to tell you whether or not the relations between each individual variable and the dependent variable is statistically significant, as it were. And it turns out that that essentially of the variables that we chose, all of them have statistical significance, except for the calculated number of host listings. So it turns out that the p-value in that case is 0.06977, and that is above the significance level of 0.05. So we can essentially say that that is not a statistically significant factor in determining the price of an Airbnb listing in New York. The rest of them did have some significance. In summary, we delivered basically an interesting message here, I think, showing, I guess, what we thought were the 2 variables that had the highest correlation to the price listings at Airbnbs in New York City, and that was of excuse me. That was of the room type and the neighborhood group. Those seem to have the highest correlation values there for that data being significant. And so what we thought would be a good idea to do would be to take some data visualization and show that data in box and whisker form. So side by side box and whisker form, and those, if you remember, those were the 2 variable categories that we actually needed to create a dummy variable. So we had numerical data to go off of. And there were some outliers in price that to make this data visualization work, we had to remove, but we were able to manipulate the data in a way and organize it in a way that so you could see side by side box and whiskers for um, the statistics for being an entire house and the prices related to those listings versus not being an entire house and the prices related to those listings. And you can see pretty clearly on this box and whisker the difference in the distribution of the prices for those types of listings. So you can see in visual form what seems to be corroborated in the data and in the data analysis. Similarly, for prices, um, we did a side by side box and whisker for the price distributions of listings in Manhattan versus non-Manhattan. And again, you can see the pretty obvious differences between the prices there. And those were the two, I guess, more indicative factors of the variables that we chose. We can compare that to be a different variable that seems to have a little less correlation, like the number of views. You can see that when you look at the visualization there, there's not a significant correlation there, and it just looks like mostly sort of jumbled up data points, and there's no clear trend that can be visualized very well there. So well, the way we ended up finalizing everything is by talking about how if one would want to try to predict what a Airbnb listing would be on the market in New York, or you could basically take that regression data and formulate the regression equation, and then you would have a coefficient for each of those variables and an intercept that you could utilize that formula, where that formula, if you want to hear it sort of read off, would be the price equals 112.46 times the room type, which is either the entire house or not, 1 or 0, plus 59.3 times neighborhood group, either Manhattan not, which is 1 or 0, plus 0.15 times minimum nights, minus 0.21 times number of reviews, plus 0.06 times calculated host listings. That number gets smaller and smaller there. And the calculated host listings, which didn't even turn out to be statistically significant, is the I guess the least weighty of all of those different variables. But you could at least to get some sort of prediction model going for some random listing in New York. If you knew what those features of those variables were, you could plug it into the regression equation and go ahead and predict that price. Overall, interesting assignment, and definitely something where these analytical models and methods would come in useful.